Welcome to our very last week of content. There's one remaining feature left in Ask that we need to talk about, which is what happens when you write from followed by a proposition that you've defined yourself using the prop keyword. When you have something that's defined by prop and then you write from it, what Ask does is it works out all of the possible ways that it could have been proven. Remember when you write prop, you're defining a new proposition by listing all of the possible ways to prove it. So let me show you, if I say prove that A is less than or equal to B implies whatever, I say by I, and then I say from A is less than or equal to B. Now Ask will generate two subgoals, and these correspond to the two different ways in which our given A less than or equal to B could have been proven. Let me quickly do some renaming. So the first subgoal corresponds to the case in which A less than or equal to B was proven using the LEZ rule. So in that case, we know that A must be 0. So Ask generates an equation for us, A equals 0, and it gives this to us as a given. In the second case, where we suppose that A less than or equal to B was proven using the LESS rule, then we know that the two variables both look like successors, and we also know that this subgoal must have been proven as well. So Ask will generate three givens for us. Two of them are equations that say that the variables A and B must look like this. And then a third one, which is an inequality that corresponds to being given the subgoal. And then in both cases, we have to prove the thing that was previously the goal. Okay, and I've explained this for the example of the less than or equals to prop, but the same idea does apply for anything that's defined by prop. Okay, so let's use this to do a serious proof. Let's prove that if A is less than or equal to B and B is less than or equal to C, then A is less than or equal to C. So this says that inequalities can be chained together. Okay, so I'm going to say inductively A. So we're going to do proof by induction on A. So these are all natural numbers still. And then I'm going to say by imp I. Now, at this point, I'm still being asked to prove an implication. So it looks like I should do by imp I again, but it turns out to be a good idea to wait until later to do that. So at this point, I've been given an inequality, A is less than or equal to B. So I'm going to say from it at this point. Okay. Now we have the two cases corresponding to whether A less than or equal to B was proven using LEZ or using LESS. Let me quickly do a bit of renaming. Okay, now in the first case, we know that, so this is the case where we suppose that A less than or equal to B was proven using LEZ. So we know that A is 0, and Ask actually substitutes 0 for A in the goal. So now we have to prove something implies that 0 is less than or equal to something. So this is easy to prove. I can say by imp I. So now I have a goal to prove 0 is less than or equal to C, and I can prove that by LEZ, because that says that 0 is less than or equal to anything. Okay, now in the other case, if A less than or equal to B was proven using LESS, then we get our two equations and an inequality. And ask has substituted for A and B, these two equations, in our goal. So this is the reason why I didn't use a second by imply earlier, because here, if this had been a given, I could have turned this part into a given earlier, but then ask would not have done this substitution for B in it. So by keeping this around in the goal for longer, ask has done a bit more work for me. So now I'm going to say by imply. Okay, so now I have another given that the successor of B prime is less than or equal to C. So at this point, I'm going to say from that. And now something a bit interesting happens. So I have told you that when you say from an inequality, you will get two subgoals corresponding to the two ways that it could have been proven. But ask, in this case, our left-hand side is already a successor. And ask is smart enough to notice that this could not possibly have been proven using the LEZ rule, because that only applies when the thing on the left is 0, and a successor can't be 0. So ask is smart enough to detect that this could only have been proven using the LESS rule. And also, so the one subgoal we have corresponds to that case, and it also only generates one new equation for us, the one for C, because and the inequality that it gives us is that B prime is less than or equal to C. So it knows that it can reuse this successor of B prime here. Okay, so now we have to prove that a successor is less than or equal to another successor. So we can do this using the LESS rule. So now we have to prove that A prime is less than or equal to C prime. And at this point, we're almost done, because this is the conclusion of our inductive hypothesis. So what I'm going to do is I'm going to say from the inductive hypothesis. And remember back to week 1, the implies connective brackets to the right. So this is this. Sorry, I need to add my primes here because we're getting smaller. This bracket's to the right. And we have A prime is less than or equal to B prime as a given. So this thing is a way of turning the fact that A prime is less than or equal to B prime into the fact that this implication. So when I say this, I'm going to be given that B prime is less than or equal to C prime implies A prime is less than or equal to C prime. And I still have to prove the same thing, but now I really am done, because now I can say from this, and now B prime is less than or equal to C prime is a given, and the thing it gives me back, A prime is less than or equal to C prime, is exactly my goal. So now ask will accept this. And now we're done.